Okay, now in section 5.4.39, suppose that a computer chip company has just shipped 8,000 computer chips to a computer company. Unfortunately, 40 of the chips are defective. In part A, we want to be able to compute the probability that two randomly selected chips are defective using conditional probability. Now, here we can use that formula to find the rule that can be used to find the conditional probability. Now we're going to use the counting principle to find the counts. So we're going to begin with the number of ways two defective chips can be chosen. Since there are 40 defective chips, then there are 40 ways the first defective chip can be chosen. Now when the second chip is chosen, since we've selected that first chip, now there are only 35 defective chips remaining. So there are 39 ways the second defective chips can be chosen. Now using the counting principle, the total number of ways to choose two defective chips is the product of these two counts. So 40 times 39 gives you 1,560. So now we want to find how many ways there are to choose two chips. Now, since there are 8,000 chips, then there are 8,000 ways the first defective chip can be chosen. Now, when the second chip is chosen, we subtract 1 from that 8,000. Now we have 7,999 chips remaining. So that means that there are 7,999 ways the second chip can be chosen. Now again, using the counting principle, the total number of ways to choose two defective chips is the product of these two counts. So we take these two numbers and multiply to get 63,992,000. And so then, in order to find the probability, we're going to take the first result, 1,560, and divide it by the second result, 63,992,000, and we get the probability of 0.00002438. Now, the probability that the first randomly selected chip is defective is taking 40 out of the 8,000, which is 0.005 or 0.5%. And what we want to be able to do is compute the probability that two randomly selected chips are defective under the assumption of independent events. Now again, if it's independent events, you're not taking a count away. So that means you're not subtracting a number from 40 or you're not subtracting a number from 8,000. You're given what the probability is, which is 0.005. So what we're doing is that we're taking both of these probabilities, since they are independent, and then multiplying them together. So 0.005 is the first probability times the second, which is 0.005, which gives us the results of 0.00002500. Now notice that the two probabilities are nearly the same. When small samples are taken from large populations without replacements, the assumption of independence does not significantly affect the probability.